Hello everyone, welcome to the course Mechanisms. My name is Wei-Jiun. I'm the instructor for this course. So in this video, I'm going to give you a brief introduction of the course mechanisms. The purpose or the objectives of this course is to help you learn the analysis of motions of linkages, gear sets, and cams. You will learn about the analysis of displacement, velocity, and acceleration. Basically, that's the motion of a mechanism. And we will use graphical and analytical methods for you to analyze the motion of a mechanism. You'll also be asked to think about the real-world engineering applications of the mechanisms. And here's the outlines for the course. And there are probably some new terms for you, but don't worry too much about it. We will talk in more details in the future. So the outline will start with the introduction, and then we'll talk about mobility and linkage. And then we'll go into the kinematic analysis of mechanisms. We'll spend about 1/3 of the time for this course to talk about the kinematic analysis. And then in the second half of the semester, we will talk about the gears and the cams. So my teaching style, I will mainly use slides and board writing. Sometimes I will show you some video to demonstrate the motion of some mechanisms. So that will help you to understand how a mechanism works. And I will give you some homework, but that's only for you to practice by yourself. So the homework won't be marked. And talking about the attendance is mandatory for this course, but you must remember to come for the quizzes, the exams, and the presentations. Well, I will announce the time, the date for the quiz, exams, presentations on SEBA. So make sure you check the website, the SEBA website, and make sure you attend those important events. So regarding the marking, and we will have 20% for the quizzes and 25% for the midterm exam, 25% for the final exams. And the last one, well, not the last one, we will have 25% for final project. So in this final project, it's gonna be a group project. So you can find 2 or 3 people in one group to form a group, and you will be asked to submit a report and to do about 7 minutes of presentation for this project. And that will be in the very end of this course, but you probably will need to start the project around midterm. Otherwise, it will be too rushed for you to finish your project. And for this project, you will be asked to use software. I'll teach you about the inventor. The Autodesk inventor you have learned in the engineering graphics course. And we will continue to use inventor to help us to do some analysis for the mechanisms. And if you prefer other software, that's also fine. It's up to your choice. But I will teach inventor. So I think it's fairly easy for you to learn if you already know how to use inventor to draw some 3D components. Yes. And finally, there will be 5% for the participation. So that means how much you get involved in the lecture. Very important thing is do not cheat in the exam, in the quizzes. Yeah, it's not allowed. So just remember, never cheating in this course. So what will we learn in this course? Let's recall what have we learned in the first year. In the first year, I think most of you have learned statics and you have learned dynamics. So what's the difference between this course and the statics and dynamics? To summarize what we have learned in statics, I would like to summarize this course with one equation, which is summation of the force equals 0. So basically in the course statics, you learned a free body diagram. You use the free body diagram to analyze the force equilibrium of a rigid body or rigid bodies. And basically the rigid bodies are not moving. So we always use the summation of the force equals to 0. So the bodies will be balanced and will not move. And in the course dynamics, I also like to summarize the course with one equations, which is summation of the forces equals mass times acceleration. So it's very similar to statics, but the difference is right now the bodies may move. So may move with a certain acceleration, and we still use force equilibrium, but right now it's dynamics. Then how about this course? In this course, as we mentioned before, this course will focus on the motions of mechanisms. And regarding the motion of mechanism, we use another term, which is called kinematic or kinematics. Well, in other schools, they may call this course kinematics instead of mechanisms. So anyway, this term will appear often in this course. And so just remember, when we talk about kinematic or kinematics, that's all about the motions of rigid bodies. So kinematic analysis includes displacement, velocity, and acceleration, but it does not include any mass. So we won't consider the mass when we perform the analysis. So now you can see the difference between dynamics and kinematics. Kinematics is just pure motion. We only talk about the motions. We are not talking about the mass. So without mass, there is no force. The acceleration, although we have acceleration A, but there is no mass. So we are not talking about the force. It's different from F equals ma. We'll only talk about the motions. Yep. So we have mentioned a lot about the mechanisms, but what exactly is a mechanism? By the definition in the textbook, mechanisms are assemblages of solid members connected by joint. So I would like to take a pair of scissors, for example. So here it says mechanism is an assemblage of solid members. What is solid members? So take this one, for example. The solid member means this blade. This blade is welded with this handle. So we consider this one as one solid member, and this one is another solid member. So for a pair of scissors, there are two solid members. this one, this blade, and this blade. And it says the mechanisms is an assembly of solid members connected by joints. For this pair of scissors, there's one joint here. So this joint connects the two solid bodies, solid members together. So we can call this one as a mechanism. But what's the purpose for mechanism? Here I also quote this sentence from the textbook. A mechanisms transfer motion and mechanical work from one or more actuators to one or more output members. So it mentions motions. So your transfer motion. What kind of motion does this pair of scissors transfer? So when we use these scissors, I push this handle and this blade, and then they will cut something. I mean, I can use this one to cut paper or cut the wire, something else. When I push this one, the output here on the blade is, I push this down, the blade is moving up. So it transfers this type of motion into another motions. So this mechanism is transfer motions. And it also transfer mechanical work. So I input some work by my fingers here, and this blade will output some work and use the work to cut the paper or cut the wire. Yeah, so that's how a mechanism work. And in the future, we'll introduce more mechanisms, and they will do different type of motion transformation and work transformation. But we'll see more mechanisms in the future. Yeah. So this is another example of a mechanisms. This one is called a crank rocker mechanism. So we can see the video, and here we consider this one as the input. The short link is called the input, and this one is the output. So we can see the video. The input is going to do a circular motion, and the output is swinging. So that's the trajectory of the output link. That's trajectory of the input link. You can see through this mechanism, we can convert, we can transfer a circular motion into a swinging motion. So this mechanism transfer motions from circular into swinging. And that's the reason why it's called crank rocker. Here, we'll talk about this later, but here I just give you a brief idea. If a link can do a circular motion, a full circle, then we call that link a crank. And if it's swinging, then we call it rocker. So in this case, the output is a rocker, the input is a crank. So we call this one a crank rocker mechanisms. So let's take a look of another example. Here is an 4-cylinder engine. Let's see how it's going to. So when this engine is running, you can see there's piston. We just take a look at first one. The piston is moving up and down, and it's transferring the motion to the shaft. And the shaft is rotating. So this one is also a mechanism. It's transferring the linear motion of piston into a rotational motion of the shaft. Yeah. Let's see the video again. So for engine, there's combustion happen here. So the combustion will push the piston down, and the piston will push this thing and push this shaft, make a shaft to rotate. So this mechanism is transfer motion from linear motion into rotational motion. And that's another mechanism. This gear set, or more specifically, this one is called planetary gear. So it's like sun and planet. We call the central gear sun gear because it's right at the center. And we also install some smaller gear. We call them planet gear, 3 planet gear. So you can see this mechanism. The sun gear is rotating, and it will bring the three planet gear also rotate. And right now we install a frame on the 3 planet gears. So you can see as the central gear is running. Go back a little bit. When the central gear is running, pay attention to the frame. The frame is also rotating, but with a slower speed. You can see the central gear is running faster than the frame. So this mechanism is transferring rotational motion into another rotational motion, but the rotational motion, the input with higher speed, but the output has lower speed. So it's also transfer the motion from one type of faster rotational motion into a slower rotational motion. Well, in our daily life, we can also see many other examples, many other mechanisms. So, for example, this, I don't know how to call this, but we know this mechanism. This cloud is gonna rotate. Then we can use this cloud to plow something, plow the soil, plow the ground, and the actuator is here. It's usually the hydraulic actuator. For hydraulic actuator, is doing a linear motion. So we use a linear motion and through this mechanism to make this cloud to rotate. So it's also transferring one type of motion into another type of motion. And another example, you can often see this in a gym. The input is this bar. So when you are doing exercise, you push this bar, and there are some cable, there are some linkages here. So eventually you push the bar here, but it will lift the weight here. So it's also transferring the motion from one type of motion into another type of motion. Although they are both linear motions, but it may be scaled down or scaled up. Yeah, I mean the movement may be scaled down or scaled up. Yeah. So that's basically the introduction of this course. We briefly introduce you the mechanisms and what we are going to mention in this course in the future. We will talk about the kinematic analysis in the future. So thank you for your watching. I will see you in the next video.